This is why the smartest people in history made their gravest mistake. Geniuses like Einstein, Fermi, and Oppenheimer sought to save the world from tyranny, only to create an instrument of its complete annihilation. We will show you the precise moment they first witnessed their creation, and reveal the ancient phrase that escaped Oppenheimer's lips when he realized what they had done. We'll delve into what compelled Albert Einstein, a devout pacifist, to initiate the development of the most lethal weapon ever conceived. We'll see how an entire city was secretly built in the middle of a desert. And we'll understand the simple physical phenomenon, the nuclear fission chain reaction, essentially an attempt to replicate the star-feeding process here on Earth that underpins a power capable of erasing civilization. The primary catalyst was fear. Intelligence reports left no doubt Nazi Germany, led by Werner Heisenberg, was alarmingly close to developing a nuclear weapon. Their uranium club was headed by a Nobel laureate. This wasn't merely a race between nations, it was a shadowy duel among the planet's greatest physicists. Imagine discovering that your mortal enemy has nearly assembled a weapon that doesn't fire bullets but obliterates cities from the map. You have no choice. You must build it first. It was this palpable fear that prompted Leo Szilard and Albert Einstein to write their letter to President Roosevelt. A few paragraphs of text set in motion a $2 billion endeavor, an amount equivalent to over $30 billion today. This sum exceeded the entire cost of building the Panama Canal, with much of it spent covertly from the president's secret funds. Einstein would later refer to this as his single greatest mistake. Imagine for a moment, you possess knowledge that could save your country, yet its application would almost certainly kill hundreds of thousands of innocent people. Would you disclose this knowledge to the authorities? There's no right answer, but this was precisely the choice they faced. To persuade Roosevelt, his advisor reminded the president how Napoleon had dismissed engineer Robert Fulton, who proposed building a fleet of steamships. Napoleon missed his chance. Franklin, the advisor stated, we must not repeat that mistake. It was this anecdote rather than complex formulas that moved Roosevelt to declare, this requires action. The machinery was set in motion. All that remained was to find the person capable of leading it, and that person was a walking paradox, a genius, a connoisseur of poetry, and the future destroyer of worlds. His name was J. Robert Oppenheimer, a theoretical physicist who quoted Sanskrit and loved horseback riding. He was chosen not only for his intellect, but also for his fervent ambition. The project's military director, General Leslie Groves, was initially appalled by the nomination. Oppenheimer held no Nobel Prize. He was a theoretician with no management experience. Groves later described him as a neurotic genius, but conceded that his over-ambition made him ideal. He gathered them in a secret city, built from scratch in the middle of the desert, Los Alamos. Scientists lived there with their families in complete isolation. Their mail was censored, and their work address was simply P.O. Box 1663. Secrecy was so absolute that the birth certificates of children born there listed their place of birth as P.O. Box 1663 Santa Fe. These children were literally born into secrecy. Within this clandestine world worked Enrico Fermi, the architect of the first nuclear reactor, Richard Feynman, a young genius and safecracker, and Edward Teller, already obsessed with the idea of an even more powerful hydrogen bomb. General Groves famously called this group the greatest collection of eggheads ever seen. It was a team of titans, each convinced he was the smartest person in the room. Meanwhile, their wives lived in a peculiar world. A well-organized concentration camp was how Laura Fermi, Enrico's wife, later described it. Your husband would leave for work at some Site Y. You had no idea what he was doing, only that it was supposed to end the war. Surrounded by rumors and barbed wire, it was an unsettling existence. The team was assembled, the city built, but they faced a seemingly insurmountable problem. They knew what to do with the atom, but not how to do it without detonating half of New Mexico. The primary challenge was dubbed the implosion problem. There was also another more existential concern. Physicist Hans Bethe calculated whether their blast might ignite the Earth's atmosphere. The probability was negligible, but not zero. At the core of everything lay one simple principle, the chain reaction. Imagine a field littered with mousetraps, each holding 2 ping-pong balls. Throw one ball. It triggers one trap, which launches 2 more. Those in turn activate 4 others. 4 become 8. This avalanche unfolds at an unthinkable speed. The first 80 generations of the reaction, releasing the primary energy, occur in less than a millionth of a second. This cascade could be initiated using 2 substances, uranium and plutonium. Thus, 2 projects were born. The uranium bomb, little boy, was as simple as a hammer. Its gun-type design merely fired one piece of uranium into another. Scientists were so confident in its mechanism that they didn't even bother to test it. It was akin to testing whether a bullet would exit a barrel when the trigger was pulled. Plutonium, however, was a different beast, more powerful, yet less stable. The gun-type method wouldn't work. The only solution was implosion, a perfectly symmetrical, inward-directed explosion. Imagine needing to compress an orange into a tiny ball by applying equal force from all sides simultaneously. Any error, and you'd simply splatter juice across the table. This audacious idea was proposed by physicist Seth Nettermeyer. Initially, colleagues deemed it impractical. It was an outsider's gamble that ultimately became the key to the entire project. This led to the gadget, the prototype plutonium bomb. It was a sphere resembling a soccer ball with a plutonium core at its center. The complexity lay in the details. 32 blocks of explosives surrounded the core, each with its own detonator. All had to fire within a millionth of a second of each other. The slightest misalignment, and the costly plutonium would simply be scattered across the desert. The theory was brilliant, but there was only one way to test it. This method was codenamed Trinity. On the night before the world changed, a thunderstorm raged. Scientists placed bets on the blast's yield, from a complete fizzle to 18 kilotons. Fermi jokingly took wagers on whether the explosion would destroy only New Mexico or the entire world. The tension was so immense that meteorologist Jack Hubbard pleaded with General Groves to postpone the test. He feared a stray lightning strike might trigger the detonation. Groves threatened him with a court-martial if he couldn't provide a favorable forecast. Then, a voice on the radio counted down the final seconds. Oppenheimer, emaciated from stress, clutched a support pillar. Everyone lay on the ground, wearing dark glasses, in the dead silence of the desert. A moment before 0, he murmured a line to himself. Lord, how heavy are these matters on the heart? First came the flash, silent, blinding, brighter than the midday sun, then a wave of heat, and only after that, a deafening roar that echoed against the mountains. A mushroom cloud ascended 12 kilometers into the sky. The light was so unearthly that a blind girl 190 kilometers away asked her brother, "What was that flash?" For the first time in her life, she had seen light. The euphoria of scientific triumph evaporated in an instant, replaced by the gravity of what had been done. Test director Kenneth Bainbridge turned to Oppenheimer and said, "Now we are all sons of bitches." And to Oppenheimer himself, other words came to mind from the ancient Bhagavad Gita. I am become death, the destroyer of worlds. Until that moment, it had been theory. After the flash, it was reality. At 5:29 a.m. on July 16, 1945, humanity passed a point of no return. And it was not a metaphor. We had created and released plutonium-239 into the atmosphere, an artificial element that had not existed in nature until that day. We had altered the planet's chemistry. The weapon was ready, but its original target, Nazi Germany, had already capitulated. Now, President Truman faced the most terrible choice in history. The war with Japan continued. The planned invasion, Operation Downfall, was predicted by military strategists to become a bloody slaughter, potentially costing up to 1 million American lives and extending the conflict for another year. The bomb lay on the table as a terrifying, yet swift, alternative. On one side of the scale were their own soldiers, on the other, hundreds of thousands of Japanese civilians. The selection of targets became a cold, bureaucratic procedure. The committee discussed cities as if choosing a location for a new factory. The criteria were simple: military significance and maximum psychological impact. It was Secretary of War Henry Stimson who insisted on excluding Kyoto. He had spent his honeymoon there, admired its culture, and did not wish to go down in history as a modern barbarian. This personal, almost sentimental motive saved the ancient capital. Not all creators of the bomb remained silent, however. Leo Szilard drafted a petition advocating for a demonstration blast over an uninhabited area, offering Japan a chance to surrender without colossal casualties. 70 Manhattan Project scientists signed it. This represented the stance of a significant portion of the individuals who had built the weapon and were now horrified by its implications. Their protest was ignored. On August 6, 1945, the Enola Gay bomber took to the skies. To underscore the mission's gravity, each crew member was issued cyanide pills in case the plane was shot down. Pilot Paul Tibbets felt nothing but a sense of duty fulfilled. But on the ground, beneath the flash of a second sun, the world turned to hell. The energy released over Hiroshima was equivalent to the complete conversion of 1 gram of matter into pure energy, according to Einstein's famous formula E equals mc squared. A theory written in chalk on a blackboard had become a reality that incinerated cities. In a single instant, the center of Hiroshima simply vaporized. In America, they were hailed as saviors of the nation. But behind the triumphant facade, a sense of guilt grew. Oppenheimer approached President Truman and stated, "President, I feel I have blood on my hands." The reaction was icy. Truman would later tell his Secretary of State, "I don't want to see that son of a bitch in my office ever again." To the president who gave the order, Oppenheimer was merely a crybaby scientist. The father of the atomic bomb transformed into its chief critic. He became a fervent opponent of the arms race and the creation of an even more powerful hydrogen bomb. His triumph became his curse. The culmination of his downfall was the humiliating hearing of 1954. His former colleagues, including Edward Teller, testified against him. Ultimately, the father of the atomic bomb was stripped of his security clearance. The country for which he had created the greatest weapon no longer trusted him. Put yourself in his shoes. You stopped the most terrible war in history, yet your creation became an eternal threat. And the country you saved calls you a traitor. The line between hero and villain becomes indistinguishable. The Manhattan Project didn't just end World War II. It ignited the Cold War and gave birth to a doctrine that forever changed the rules of geopolitics. Politicians and military strategists quickly coined a chilling acronym for this new reality: MAD, Mutually Assured Destruction. This principle posits that the only thing preventing the world from nuclear apocalypse is fear. The fear that an aggressor would be just as completely annihilated in a retaliatory strike. We still live in the world born from that flash in the desert. This story leaves us with 3 simple yet uncomfortable truths. First, technology possesses no inherent morality. Nuclear fission can power cities or incinerate them. The tool itself is entirely neutral. It's like fire. It can warm a home or burn it to ashes. All responsibility lies not with the flame, but with the one who ignites it. Second, great objectives can justify monstrous means. The drive to defeat the absolute evil of Nazism led to the creation of a weapon capable of destroying all humanity. This serves as an eternal warning about how easily one can cross a line when convinced of their own righteousness. And third, knowledge cannot be uninvented. Once Pandora's box has been opened, it cannot be closed again. The knowledge of nuclear weapons is like a genie released from its bottle. It cannot be put back. We can only learn to live with it, hoping that no one will ask it to grant its final, most terrible wish. Ultimately, the story of the Manhattan Project is one of choice. So what was it? A brilliant calculation that saved millions from a prolonged war, or a monstrous mistake that pushed the world to the brink of self-annihilation? Write just one word in the comments: calculation or mistake. Let's see which prevails.